So today we're going to go over the second lesson, which is the lesson number 2, application of prime factors. So we have previously learned in lesson number 1 how to prime factorize. There were two methods that we used. One was the division method table. So you start with your number and you think of a prime number, in this case a 2. So you could try with a 2, a 3, a 5, a 7, and then you divide it by that and you keep going until you get to 1. So that's the division table to do prime factorization. The second method was the tree diagram. So let's say the same thing, and this works really well if you know of two numbers that will multiply to become 48. So 4 times 8 works. You could have done any other combination, but you break it down. So this kind of indicates that you broke down into two parts. And then you take one of it, so let's say 6, and you again try to think of how you can divide this up. So it will break down to 2 times 3. Now, anytime you hit a prime number, I suggest you circle that because we know we've kind of got to the end of that tree, kind of like a leaf, right? So both 2 and 3 are prime factors. That means we don't need to go any further. So you're done with this side, this branch. Then you move your attention to the other side of the branch. So 8 can be broken down as 2 and 4. And once again, 2 is a prime factor. And then 4 can be further broken down into another 2 and 2. So either way, for either way of these methods, the tree diagram or the division table, you end up with the same factor, prime factors. So here are your prime factors in the tree diagram. And here are your prime factors in the table format. So we're going to take this method and we're going to apply it in today's lesson, which is going to be finding the greatest common factors between two numbers or the lowest common factors between the two numbers. So those are the two things that we're going to learn in today's lesson. And you can use either one of these methods or another method that you may know or comfortable with. Okay. So our first thing that we're going to learn today is going to be about the greatest common factor. Okay. So this is on page 7, and it's asking us to find the common factor between 8, 12, and 20. So the first thing I would want to do is break down my 8. So either use your table or your tree diagram. So this becomes 2, and this gets broken down to another 2 and 2. So what I want to do is, the way I do this is I write down my number, and then I write down all its factors. Okay, and then I go ahead with the second one, and I again break it down. Again, this is going to be 2 and 8. You could just use the 8 from the previous example, but if you want, you can again break it down. Sorry, that should have been a 4 here first. Don't know why I'm circling it. Okay, there we go. So, and then this time we have one more prime factor, so it's going to be 2 times 2 times 2 times 2. So these are all the prime factors I got from 16. And then one more time with 20. So 2 times 10. And this can be broken down to 2 times 5. You could have done 20 as 4 times 5 if you wanted to, and that would have been the same answer as well. Okay. So far what all I have done is I have done my prime factorization. Okay. And I like doing this method always is because this has a little bit more connection to it as we go in higher in math. So we'll see in math 20-1, 20-2, and so on. When we move away from numbers and start using variables, the prime factorization method works the best. Okay. So we're going to take a look at it here. Look for a factor that is in all 3 of them because we're looking for the greatest common factor. So we're looking for a factor which is common between all of them. So the word is that is common between them. So this one is 2 is in each one of these factors. So this 2, I'm going to count it only as once. Okay, so I'm going to say this 2 was available in all 3 of these numbers. So this is common to all of them. I'm going to see if there's another one that is common to all 3 of them. So in this case, it's going to be this one right here. So this is again common in all 3 of them. Okay, so that again now tells us that those are the common ones. Then I try to see if there's another one that's common. Well, I have a 2 here and here, but it's not common in the last one. There's no another extra 2 in there. So this will not be counted as a common factor. And then again, this 2 is only here and this 5 is only here. So these ones will not be counted as greatest common factors. So the greatest common factor, GCF, is going to end up being 2 times 2, the ones that we just found common in all of them. So that means 4 would be the number that is a greatest common factor. So think about this one. What number can divide all of these? The biggest number that will be able to divide all 3 numbers would be 4. So 4 can divide 8, 16 can be divided by 8, and then 20 can be divided by 8. That's what we look for, the greatest common factor. The biggest factor that was common to all of them, that can then go in and divide all 3 numbers. Okay,